Assalamualaikum and hi. Okay, today I will recap back on angle modulation. Okay, so after studying this chapter, you should be able to have this thing. Okay, now in this chapter, for chapter 3, we split into two parts. The first one is part 1, angle modulation, basic principle of FM, bandwidth, AM versus FM. And part 2 is the frequency modulation transmitter, frequency modulation receiver, and noise in frequency modulation, pre-emphasis and de-emphasis. Okay. So basically, previous slide, in chapter 2, you already deal with amplitude modulation. Okay. Basically, amplitude modulation, frequency modulation, and phase modulation jump under analog modulation. Okay. Now, this one is the signal, information signal for frequency modulation, sinusoidal, carrier signal, we got the carrier signal, and then this is the output signal for FM. Okay, you can see, previous slide in amplitude modulation, we play in terms of the amplitude. But right now, when you deal with the frequency modulation, you will see something like the signal become wide and also narrow. Okay, for phase modulation, we play in terms of the phase. Okay, for information signal and carrier signal also similar. Okay, now so this is the comparison signal. Okay, we have information signal, we got carrier, but you see the difference between AM, FM, and PM. You see something like this one, we will play in terms of amplitude. Here we play in terms of frequency, narrow and wide. Here we play with in terms of phase. Okay. So angle modulation similar. We got the we can express the signal in terms of mathematical. So basically, you see something like quite similar like amplitude modulation, but right now we change it into frequency and also the phase. Okay. Now, in angle modulation, the choice between FM and PM depends on which directly varied by the modulating signal. Okay, this one for direct FM, direct PM. Okay, now you see, you want to select FM or PM. You can see this slide. Okay, now this is you can see the difference between FM signal and also PM signal. Okay. So basically in this chapter, you will learn on frequency deviation, frequency modulation index. In AM also got modulation index, Bessel function, okay, and then power analysis. Also already appear in amplitude modulation analysis. Okay, so this is the first thing that student must know. Okay, first term you will listen, you will know something like frequency deviation, delta F. Okay, you should know this first term. Okay, and then if you see the signal, you know actually Fc plus delta F actually is the F max. Okay, Fc minus delta F, F min. So this is the thing that term you must know. Okay. Okay. You can read by yourself. FM is the process changing carrier frequency by the modulating signal while the carrier amplitude remain constant. Okay. So the amount of change in the carrier frequency produced by the modulating signal, which is measured by in peak frequency deviation delta F here. Okay. Okay. Now frequency deviation. Okay. So now see the relationship between frequency deviation. This is frequency deviation. What is the KF? KF is the deviation sensitivity and VM is the peak modulated signal amplitude. Okay. Now, in deviation sensitivity in FM, we call as KF. Okay. KF shows that the sensitivity of frequency modulator. Okay, now you see the term. Okay, what is the difference between this term and this term? This one in radian. This one in hertz. Okay, now similar like amplitude modulation, the important element to do analysis in frequency modulation is a modulation in index. Okay, this one if you want to solve in terms of radian. This formula if you want to solve in terms of hertz. Okay, this one is the what? Frequency deviation. Okay, then this is the thing that we want to know. Modulation index. Delta F divided by Fm. What is the delta F? Delta F is the frequency deviation. Okay, now, so percentage of modulation, delta F actual divided by delta F max times 100%. Okay, how about you want to know in terms of sideband? In AM, you got the sideband, right? Upper sideband and lower sideband, and also the frequency carrier. But for FM, it's different. You can have many sideband or more or less, depend on your design. Okay. Now let's see this example. This is a direct example. Determine the modulation index for FM signal with the modulating frequency is 10 kHz divided by plus minus 10 kHz. So what is this? Okay, actually 10 kHz is a FM divided by frequency deviation. For carrier swing is a 2 times. Okay, so the value something like 20 kHz. Okay, this one you can solve by yourself. Okay, now remember the sideband as what I mentioned before in amplitude modulation. Okay, it's a product of any modulation. Okay, so more sideband means more immune to noise. Okay, now, okay, normally in FM we can have more for your AM. We can also only got upper sideband and lower sideband, but in FM different. You can add more. Okay, it depend on your design. Okay. How about the bandwidth? The bandwidth also different. Okay. Last time for AM you just take 2FM for example. Right now it's different from here to here the bandwidth. Okay. Now how to solve something like this one? This is the FM equation. Similar, you can see something like this one is the information signal. Okay. No, this one is the carrier signal, VC. Okay. Okay. So identity similar like quite similar like AM. We play with the trigonometric identities. So we expand using the Fourier field series. You got this formula for even, and then this equation for odd. Okay. We can substitute in the VFM. We do analysis. We substitute. When you substitute, finally you can get this formula. Using the basic entities, you got this thing. Okay, what is this? This thing something like we want to show you in terms of sideband 1, 2, 3, 4 till n. Okay, now what is the Bessel function? Bessel function actually we want something like okay, this is Bessel table. Actually, in Bessel function, we got M modulation index. This is the term you must know. VC is the peak amplitude. J naught equals to carrier component. Remember, J1 is the first side frequencies. Second, Jn means n set of side frequency. So from here, you can see something like, I'll show you something. For example, here, if your modulation index equals to 2, how many significant sideband? For example, here, 4. Why 4? Because you got here, from here, 4. 4 means what? 4 means left 4, right 4. Because sideband in pairs. Okay? Now, this is Bessel function of the first kind. Okay? Now, we want to know, okay, this one 2, right? This one, how about the modulation index when you do analysis equals to 1? So from here, how many sideband? You got 1, 2, 3. Sideband mean in pairs, so you got 3 on the left, 3 on the right. Okay. Now, how you want to put the value? Okay. For example, here you want to know in terms of the voltage, right? What is the voltage here? 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 Okay, very easy. For example here, modulation index equals to 1. You refer here. Modulation index equals to 1. So, how about the frequency? Okay, right now, EC, you direct take the carrier signal. Okay, in this case, how to arrange the value from the Bessel table? You see here, for example, M equals to 1. You take 1. 0.77 you put here. Okay, 0.44 you put here. 0.11 you put here. 0.02, okay, you put here. You must multiply with EC. How about the frequency here? Okay, frequency here for frequency domain FC, okay, similar like AM, FC. Here FC plus FM, FC plus 2FM, FC plus 3FM. If you got another one, FC plus 4FM. Okay, here how about here? FC minus 1FM, FC minus 2FM, FC minus 3FM. Okay, now we already see this thing, okay. Right now, let's see how about m equals to 2 equals to 2. You take this value 0.22, okay, 0.58, 0.35, 0.3, 0.03. So EC, how about depend on your design. Let's say EC equals to 50 volt. You multiply 50 volt times this one, 50 volt plus this value, times this value, 50 volt times this value, okay, or time by EC. Okay, now this is some, we give you an analogy. If we give you EC equals to 50 volt, M equals to 1, then what happen? You multiply 50 volt times the 0.77. How you get here? M equals to 1. Okay, 0.77. 50 times 0.77, you got 38.5, and you can calculate by yourself. Now, we go to power analysis. Okay, similar like AM, we need to study the power. Okay, so basically in power, total power in FM, PT plus P0, P0 plus P1, P2 plus Pn. You also can write down in terms of PT, V0 squared divided by 2R plus 2V1 all squared divided by 2R. Then you can see, okay. Then when you use Bessel table, then further improve equation, you can get this formula. EC squared J naught squared 2 multiply the side band. Why we put 2? Because we got pair. Okay. So how about the bandwidth? Okay. Remember in AM we also do analysis on bandwidth. FM also same. Okay. Bandwidth we got this one Carson rule, bandwidth 2 multiply by what is the delta F? Delta F is the frequency deviation plus FM, information frequency, and then FM bandwidth, actual bandwidth, using Bessel table, bandwidth 2 times N. What is the N? N something like here. Okay. For example here, if M equals to, for example, 2, M equals to 2, and how many M? 1, 2, 3, 4. So you put 4 here times the frequency of the information signal. Okay. Okay. This is the solution. For example, we take the highest frequency 3 kHz and the maximum deviation is 60 kHz, and then you find the using this information you can find modulation index. So you got 2. So 2. How about the N? N means of your sideband. Why 4? Because here 1, 2, 3, 4. Clear? And then how about the Carson rule? You find the 2 times delta F. Okay, delta F. Okay. How about delta F? Delta F you time equals to 6. Okay. And then plus FM. FM equals to 3 kilohertz. So you got total 18 kilohertz. Okay. So the rest you can do by yourself. You can see the example given. Okay, try to do the exercise. Okay, and then if you don't understand, you can asking me. Okay, so finish part 1. Thank you.